Okay. In this application problem, we're asked to, as the angle of elevation from the top of a tower to the sun decreased from 72 degrees to 56 degrees during the day, the length of the shower of the tower increased by 84 feet along the ground. Assuming the ground is level, find the height of the tower. So let's take a look at what this might look like. Okay, so originally we had our sun and we had a tower here. This is my tower. Okay, and the sun's angle of elevation, now what that means is looking from the top of the tower across the horizontal line, the angle opening up there, it says was 72 degrees originally. And then on the other side, notice that the sun's over here. The sun would cast a shadow of the tower this direction, and that shadow, it says it was increased by 84 feet. So originally it was just the length of x. Okay, so this is one situation that we're looking at. Okay, but then as the sun went down further in the sky, okay, we still had our tower, we still have the sun, but now our angle of elevation is only 56 degrees. It decreased from 72 to 56 degrees, that angle that you're looking up at the sun. Okay, well, notice what that would do is that would also lengthen our shadow, and it lengthened our shadow by 84 feet. So it was originally, we called it x feet. The shadow's now x plus 84 more feet. Okay, so think about it. The shadow would increase as that sun goes down. It makes the shadows on the ground, makes them longer. Okay, so these are our two situations here. We are asked to find the height of the tower. So I'm going to call that h, and we are dealing with the same tower in both drawings. So those would be our h. Okay, well, one thing that we're dealing with here is angle measure. So we have two parts of the triangle, but we want to find this angle here would be helpful to solve this problem, and this angle here would be helpful to solve this problem. So what I'm going to actually do is, you see my horizontal line here, I'm going to just extend that across. Okay. Okay, notice this height here would still be h. This distance here would still be x. Forms a rectangle. And now I know this angle here. Why do I know? Well, in geometry, hopefully you studied vertical angles. When two straight lines intersect, they form a pair of vertical angles, and vertical angles are always congruent. So that would make this angle 72 degrees. Right? On this figure over here, I'm going to do the same thing. I'm just going to extend my horizontal across, down. This height is still h. This distance is still x plus 84. My angle, again, I have two lines intersecting. They form vertical angles, making this 56 degrees. Okay, so I'm going to now outline the triangles I'm going to use to set up my equations. I'm going to outline those in blue. Okay, so here's the triangle I'm working with in blue here. Let's set up an equation. Well, what do we have? We have an angle. For that angle, we have the opposite and the adjacent side. What trig function uses opposite and adjacent? Well, that is tangent. A tangent of any angle in a right triangle is the opposite side over the adjacent side, and that's what we're equipped with for our information. So let's put our information into that. So tangent of our angle happens to be 72 degrees equals the opposite side h over the adjacent side x. In this triangle here, we have the same situation. We have the opposite side and the adjacent sides for our 56 degree angle. So tangent of the angle here is 56 equals the opposite side. The side opposite that is h. The side adjacent to it or touching it is x plus 84. Okay. What we want to do here is isolate some variable, and really the easiest one to isolate would be h. Notice it's in the top of each fraction. So I'm going to multiply both sides by x here, because that will remove x from the denominator, and I will be left with h equals x times the tangent of 72. Here, if I multiply both sides by x plus 84, the denominator, that will clear the denominator, and whatever I do on one side, I have to also do on the other. Okay, so here I'm left with x plus 84 times the tangent of 56. All right, notice I have h equals and h equals. This is equal to h and this is equal to h, therefore they must be equal to one another. My next step is going to be to set those two values equal to each other. So x plus tangent 72, not plus, sorry, times the tangent of 72 is equal to, I'm going to go ahead and distribute this here, x times tangent of 56 plus 84 tangent 56. Okay, so those two values, I set them equal, and again, I just went ahead and did my distributing there just to save myself some room. Okay, we are still solving for a variable here. The variable we have is x. So to isolate it first, so we need all x's on the same side. So this x tangent 56 is going to have to move to the other side. It was positive, so if I subtract it from both sides, I will have it moved. Okay, so now I have x times the tangent of 72 minus x times the tangent of 56 equals 84 times the tangent of 56. I have my x's over here, but I need just a single x, and notice using factoring I can do that. If I just pull an x out, then I'll have x times the tangent 72 minus tangent 56 equals 84 times the tangent of 56. Last thing to get h by itself is to divide. It was multiplied by this subtraction here. So if I just divide both sides by the value of tangent 72 minus tangent 56, I will have x all by itself, and all I need now is a calculator. I need to find out what 84 times the tangent of 56 divided by tangent 72 minus tangent 56. Now I would not try, unless you're very good with your parentheses, to put that all in your calculator. Maybe find each part and then do your calculating. Okay, so you would subtract these two on the bottom, multiply these in the top, and then take the top divided by the bottom. Either way, you should end up with about 78.07. You may be off just a bit if you did some rounding along the way. You should be around 78. Okay, so that's x. Is that what I was looking for? No. X was the length of the shadow if we go back to our figure. Okay, so our shadow, our original shadow, was about 78.07, and this one was 84 more than that. But we wanted the height of the tower. That's our h. So now we're going to take that back up here, where we knew h was equal to x times the tangent of 72. I now know that x is 78.7 approximately. Again, rounding will change your answer just a bit, but you should be close. Okay, so if I multiply those, 78.07 times the tangent of 72, I get about 240.3 feet. Okay, so again, not a complex problem. If you draw it out, you go one step at a time, makes it more doable. Okay, here's another application. It says two banks of a river are